Alright, welcome back everybody. In this video we're going to talk about finding compound probabilities. Specifically we're going to talk about compound probabilities for AND statements when the events are independent. And one of the things that's going to be really important for you over the next couple of videos is being able to recognize whether you're dealing with an AND probability or an OR probability. And if you're dealing with an AND probability, are the events independent or are they dependent? But we'll talk about that more over the next couple of videos. So what we're doing is we're finding the probability of multiple events occurring, and we're going to start with a quick definition of what independent events are, because you need to understand the difference between those and dependent events. Independent events are two events where the probability of one event occurring in no way affects the probability of the other event occurring. Suppose I roll a die and I flip a coin. What I roll on the die has absolutely no impact on what I flip on the coin, so those two events are independent of one another. And when I have two independent events, I'm going to find the probability of both of them happening by using this formula right here. The probability of both A and B occurring is just equal to the probability of A occurring times the probability of B occurring. So it's very simple to find a compound probability when the events are independent. Let's go ahead and look at a few examples. We'll start. Omar flips a coin and rolls a standard 6-sided die. Find each of the following probabilities. The probability that he flips heads and that he rolls a 6. So this is equal to the probability that he flips heads times the probability that he rolls a 6. Because these two events are independent. Whether one happens or not has no impact on the other. So if you flip a coin, the probability of getting heads, there's one head on a coin out of the two possible outcomes. So the probability of heads is 1/2. The probability that he rolls a 6 on a die, there are 6 possible outcomes, one of which is a 6. And so to find the probability that he flips heads and rolls a 6, we're just going to multiply these two together. 1/2 times 1/6. And if you have trouble working with that kind of stuff, go ahead and use your calculator. We've got 1/2 times 1/6. Come on. And my calculator will give me the decimal. I can have it change it over to a fraction by using my math key. And so my probability is 1/12. Again, we can write this as a decimal. You already saw the decimal on my calculator screen the last time. Or we could write it as a percent. So any of those three would be a good answer, depending on what I ask for. Alright, part B, the probability of tails and less than 3. So that's going to be the probability of tails times the probability of less than 3. Probability of tails, there's one tail out of two possible outcomes. There are 6 outcomes when I roll my die. How many of those are less than 3? Well, there's 1 and there's 2. Those are both less than 3, but that's it. And I'll multiply those two fractions together. I'm actually just going to go ahead and cancel the 2's out, and that's going to be 1/6. Or if you decide to turn it into a decimal, 0.1666, or as a percent, 16.66%. Okay, on to the next example, finding probability of independent events. The weather forecast says that there's a 70% chance of rain on Saturday and a 40% chance of rain on Sunday. What is the probability that it will rain both days? These two are independent probabilities. Whether or not it rains on Saturday has no impact on whether or not it rains on Sunday. So I want to find the probability that it will rain both days. Since these are given as percentages, in order to do the calculations, I'm going to have to convert them over to decimals. So I want the probability that it rains on Saturday as a decimal, that is 0.70. And the probability that it rains on Sunday, the decimal for that is 0.40. And now, in order to find the probability that it rains on both days, it's the probability of one times the probability of the other. And so I'll take 0.70 times 0.40. I get 0.28. Now, since my probabilities were given as percentages in the original problem, I'm going to change this probability over for the probability of both days over to a percent. I move the decimal point 2 places to the right. The probability that it rains both days is 28%. All right, next example. Caleb has 2 bags with different types of snacks. The first bag contains 3 packs of peanuts, 4 packs of almonds, and 2 packs of cashews. The second bag contains 4 packs of gummy bears, 5 packs of gummy worms, and 3 packs of gummy Coke bottles. If Caleb randomly picks one snack from each bag, what is the probability that he will get almonds and Coke bottles? So we're looking for probability of almonds times probability of Coke bottles. Again, these two are independent because what he picks out of the bag of nuts has no impact on what he picks out of the bag of gummies. So first we find the probability of almonds. We look at the bag containing the nuts. There are a total of 9 packs of nuts in that bag. How many of them are almonds? 4. So the probability of getting almonds is 4 out of 9. For the gummy bag, there are 4, 9, 12 total items in there, 3 of which are Coke bottles. And so now I can go ahead and calculate the probability of that particular outcome. And I could have calculated this way faster in my head, as finicky as my calculator is being right now. Come on. 0.1111. If I change that over to a fraction, it's 1/9. So our probability is 1/9, or if you like decimals better, 0.1111, or as a percentage, 11.11%. So any of those would be fine answers for my probabilities there. I would probably prefer a fraction in this context, but it doesn't much matter. All right, and on to our last one here. Alex flips a quarter 3 times. What is the probability that he will flip 3 heads? Well, there's only one possible way if he flips a quarter 3 times for him to get 3 heads, and that is if every single flip he flips heads. So we're looking for probability of heads on the first toss times the probability of heads on the second toss times the probability of heads on the third toss will give us the probability that he flips 3 heads using this coin. And the probability of flipping heads on any coin toss is 1/2. And so here we see that we can extend this idea to more than 2 events. We can just go ahead and find the probabilities of each individual event, multiply those together. And so his probability of flipping 3 heads is 1/8. Now, the second question here is a little bit more difficult. What's the probability that he will flip 2 heads and 1 tail? And it's made a little bit difficult by the fact that when he's flipping 2 heads and 1 tail, there are actually multiple different outcomes when he flips his quarter 3 times that will lead to 2 heads and 1 tail. He could flip a head first, and a head second, and a tail third. He could flip a head first, and a tail second, and a head third. Or he could flip a tails first, a head second, and a head third. So there's 3 different ways that he can flip 2 heads and 1 tail, and the probabilities of each of those are the same as the probability we found in the first part here. They're all 1/8. And so to find the probability of all 3 of those combined outcomes, we're just going to add those 3 probabilities together. And so the probability that he will flip 2 heads and 1 tail is 1/8 plus 1/8 plus 1/8, or 3/8. So whenever we're talking about a multiple coin flip problem, we have to identify all the different ways that it could possibly occur in order to help us find the actual probability of that particular outcome. All right, that's the end of this video on compound probability and statements. See you guys next time, and have a great rest of your day.